The most frequently used visual to represent the results of cost-effectiveness analysis is the so-called cost-effectiveness plane. It's a simple tool that allows us to plot our cost-effectiveness frontier, visualize the willingness to pay thresholds, and distinguish between simple and extended dominance. That's why in today's video I'll break down these basics for you. Let's have a look at the cost-effectiveness plane. As you can see, it combines incremental health effects on the x-axis, which are usually expressed as QALYs, and incremental costs on the y-axis. Incremental effects simply mean that we are interested in the differences between two treatment options. We health economists like to use the little triangle or delta to signal that we are talking about such incremental effects. In this context, new treatments are usually compared against the standard of care, which is plotted at the origin, so the point where the x and y-axis cross. To assess how our new treatment compares against the standard of care, we first need to understand the 4 quadrants of the cost-effectiveness plane. Going clockwise, the northeast quadrant is where the new treatment is more effective and more costly. In other words, the new treatment has both higher costs and QALYs relative to the standard of care. Treatments that fall into the southeast quadrant manage to achieve higher QALYs at a lower cost. For obvious reasons, this is very desirable, as it means that the new treatment is improving patient outcomes while also saving money for the healthcare system. Because of high drug development costs, it's really rare that new innovations fall into this category. In the southwest quadrant, things are getting tricky again. Here, the new drugs have lower QALYs, but they also have lower costs. While this wouldn't really be something to consider in a world with endless resources, the reality is that healthcare budgets are tight and hence opportunities to achieve savings really need to be weighed carefully. Things get easier again in the northwest quadrant. Here we are looking at drugs that come in at a higher cost while generating fewer QALYs than the standard of care. Treatments that fall into this category are dominated by the existing standard of care. Now, how can we make decisions based on the cost-effectiveness plane? Like we've seen, it's easy for 2 out of the 4 quadrants. We can always accept the drugs in the southeast quadrant, and we can always reject the drugs in the northwest quadrant. For the northeast and southwest quadrants, we need to take a closer look though, as cost effectiveness of a new treatment option depends on how much we're willing to pay for additional QALYs. Let's add some treatments to our cost effectiveness plane to see how they compare against the standard of care. If a new treatment generates 2 additional QALYs at an additional cost of £150,000, the ICER will be located in the northeast quadrant. We can also think of a treatment that not only leads to greater health effects, but also to lower costs. For example, a treatment that generates 1 additional QALY while also saving £150,000. This treatment falls into the southeast quadrant, and it dominates the existing standard of care. A third scenario is that a treatment leads to worse health effects, but at the same time it also has lower costs. In this case, our ICER is in the southwest quadrant. Last, a treatment with an ICER in the northwest quadrant leads to worse health effects at a higher cost. This is where the question of cost effectiveness is easy again, as the new treatment is dominated by the existing standard of care. As you can see, we have got no closer to determining if our treatments in the northeast and southwest quadrants are actually cost effective. To get to the bottom of that, let's add a £50,000 willingness to pay threshold. The willingness to pay threshold is nothing more than a line that tells us how much money we're willing to spend per unit of health benefit, in this case measured via QALYs. In that sense, a 50k willingness to pay threshold means that we're okay to spend a maximum of £50,000 to generate 1 additional QALY or £100,000 to generate 2 additional QALYs and so forth. Now you may wonder how this helps us make decisions about the cost effectiveness for our 4 treatments. You see, a willingness to pay threshold gives us a simple yes-no decision rule. Everything that falls underneath our willingness to pay threshold can be deemed cost-effective, while everything that's above the threshold is not. In practice, however, it's not always that easy. In England, for example, NICE uses a willingness to pay range between £20,000 and £30,000 per QALY. When we plot these 2 thresholds on our cost-effectiveness plane, we see that there is room for the committee to decide if a new treatment should be reimbursed or not, as highlighted by the yellow area. In cases where the ICER falls within this range, NICE will usually decide based on the level of uncertainty that is associated with the decision. If the uncertainty is low, manufacturers have a better chance of being judged against the less strict 30k threshold, whereas the 20k threshold may be used in cases where there are lots of uncertainties. Let's look at an example to understand the cost effectiveness plane a little bit better. What you can see in this table is the cost effectiveness results for 5 diagnostic tests that could be provided to 500 people. Test A is the standard of care, which is why incremental costs and QALYs for test B to E are all represented relative to A. With these numbers, we can then plot the incremental costs and QALYs for the 5 tests on a cost effectiveness plane, whereby the line that connects these treatments represents the potential combinations of treatments. For example, we can think of a scenario in which we use test A with 250 people and give test B to the remaining 250 people. Therefore, we would expect outcomes to lie halfway between A and B. We could of course do the same with any 2 other treatments. Let's say half of our population gets B while the other half gets D. Again, results should lie halfway between B and D, but we can also do this mathematically. We simply multiply both the total QALYs and costs for B and D by 0.5 and then add them up, which gives us our combination results. So 14,000 times 0.5 plus 19,000 times 0.5, which is 16,500. If we do the same for our costs, we can then see that our BD combination generates 16,500 QALYs at a cost of 145 million, while test C alone only gets us 16,000 QALYs at a cost of 150 million. You can see that a theoretical 50-50 split between B and D dominates C, so we say that option C is extended dominated. Instead of doing this mathematically, we can also get to the same conclusion visually by drawing a line between B and D. This line represents all possible combinations between B and D, and as you can see, test C lies above this line, which is why we should remove it to draw our cost effectiveness frontier. Spotting treatments that are either dominated or dominant is easier than identifying extended dominance, as the latter requires careful consideration of linear combinations of 2 treatments and can therefore sometimes be missed. We didn't miss it though, which is why we can remove test C and draw our cost effectiveness frontier. The cost effectiveness frontier is the line connecting successive points on a cost effectiveness plane, which each represents the effect and cost associated with different treatment options, or in our case, diagnostic tests. The gradient of a line segment on the CEF represents the ICER of a comparison between 2 alternatives represented by that segment. Last, we also know that points not lying on the cost effectiveness frontier represent treatment alternatives that are not considered cost effective. Apart from presenting base case results, cost effectiveness planes are also used for sensitivity analysis. In particular, the individual iterations from a probabilistic sensitivity analysis are commonly plotted on a chart like this. Fortunately, you can easily generate probabilistic sensitivity analysis results like this in Excel. However, that is a topic for another video, so I suggest you watch one of my other videos in the meantime, which you can see on screen right now.